All right, everyone, we are going to move on in HED 241. We are now in Part B, Descriptive Statistics, Section 7, Shapes of Distribution. So, shapes of distribution. This is an example of a table that shows a distribution, frequency distribution. So, a frequency distribution table shows how many participants have each score. So, remember, the F here is frequency, and that's associated with each score. So let's say, for example, that maybe these numbers are related to the number of people who could do a specific number of push-ups in 30 seconds. Okay, so right here you had one person who did 22 push-ups in, say, 30 seconds. Okay, you had 8 people do 19, 5 do 18, 2 do 17, so forth. So your N here is your total number. So if you took all of these F's and added them up, you would get this N, which is 24. So frequency polygon. This is a graph showing this distribution table. Okay, so it's on the slide previously is what you're looking at. Okay, so right here you'll see you had the 8 participants who had a score of 19. We said it was 19 push-ups, whatever it is, okay? You had 3 that had a score of 21. So you can go down here, your scores, 21. Up, you see the frequency was 3, okay? This is a normally distributed or normal distribution of a graph. So this one you'll see, they've kind of plotted it out, but this is the previous slide. Going forward again, this is a normal distribution. It's also known as a bell curve shape. Okay, a normal distribution or bell-shaped curve graph is important for 2 reasons. One, its shape is very often found in nature. Think of height. So you know that we don't have a ton of women who are under 5 foot, let's say right here, right? Just in America, you don't have a ton of women that are 4'10", 4'11", right? You also don't have a ton of women who are 6'3", 6'4". Some, you have some here, but a majority of yours are going to be more of this average height. Not probably exactly average height in America, but it's probably around 5'4", 5'5", somewhere around in there. So you're going to have a lot more in this area than you are here. So as you see women getting, going from like the shortest woman in America to getting a little bit taller, you have more and more and more till you get to that average height, and then you're going to see it come back down as you're getting, you're like 5'10", maybe 5'11", 6 foot, keep going, okay, to your tallest. So your tallest American woman would be over here. It's also important because we use the bell-shaped curve or normal distribution as a basis for a number of influential statistics. We talked barely about influential statistics in Part A. It is in Part D of your book. We're going to touch on them just a little bit. It's not something I want you to know a ton, but I want you to know that you need normal distribution for a number of influential statistics. That's what I want you to know. And I want you to know there's 2 reasons why normal distribution is important. So again, its shape is very often found in nature, so it's usually normal. Okay, and we use it as a basis for a number of influential statistics. So what if a distribution isn't just normally shaped? What if it isn't a bell-shaped curve? So you could have a positive skewed. Okay, so a positive skew is a distribution skewed to the right. Okay, so see this, they call this the tail. It's off to the right. So skewed distributions are named for their tails. So a long tail to the right is going to be called positive. So this one is considered a long tail to the right. Many people have a low income, so the curve is high on the left. So we know in America it's not normal distribution of income. We know that there are more individuals in America that have a low income than those that have a high. Only a few people have a higher income. So we know that's the top 1%, 5% is going to be over here. Majority, you see this is not centered, right? It's off center, so it's more to the left. There's a lot, the average is a lot more to the left. Okay, so it's not in the middle. So that is a positive skew. A negative, only a few people have low scores. Okay, we're hoping on this is like every test that you all take as a class. We're hoping there's very, very few low scores and a bunch of high scores, right? So that's what this is saying. So more people have higher scores, so the curve is to the right. So because the tail is on the left side, it's negative. Okay. Another example of this would be maybe smoking and cancer, right? So if you said if you don't smoke, you don't have that many people who have chance. You don't smoke, you have low chance, right? If you smoke, you have a higher chance. Okay. Bimodal distribution. So these are really rare. It's not something I want you to focus on a ton. These two high points do not have to be exactly equal for that to be bimodal. When you see this, it goes up and then it comes down some, and it can come all the way down, or it doesn't have to come down all the way. And then it goes back up close to at least the first curve. That's bimodal. An example might be if a country's at war, then that year their death rate by age, it might be that they have a lot of younger deaths in addition to their normal older deaths. Maybe it's because the 18 to 30-year-olds are fighting the war, so they're going to have a higher death rate than normal. And so that would be an example there. That is going to be section 7 of your textbook. Make sure you read through your assignments. Regardless of what the specific questions are that you're required to answer, I strongly recommend that you are able to answer all of these questions. If you ever have a question on one of these and you want to know the answer to it because you're unsure of it, please make sure you let me know. Otherwise, as always, any other questions, let me know and I'll be happy to help. Have a good week.